Okay, welcome back. We're going to continue on taking a look at the basics to a distributed switch. Now that we've gone through the process of creating one and adding hosts to this distributed switch, adding VMs and uplinks, we're now ready to start explaining some of the other characteristics, especially if you were to take a look at port group settings pages as well as the distributed switch settings pages. So let's take a look at our first bit here. Whenever you right click on a distributed switch port group, like for instance, here we're looking at the port group called PGSA production. In the edit settings page, you'll find that you have all kinds of characteristics that you can adjust with a distributed switch, much more than say you did with a standard virtual switch, right? A standard virtual switch, you have the basics. You have the security settings, you have the traffic shaping, and then you have the teaming, and then that's really about it. With a distributed switch, we have those, but we also have VLAN on its own settings page, also monitoring and miscellaneous. What you have here is basically port group based management with a whole lot of additional features, but also the ability to manage individual ports too. So things to note here. What is unique about a distributed switch? You may be familiar with a standard switch. It offers, under the teaming options, the ability to do different types of load balancing based options. So for instance, we see them here. There's route based on IP hashing. There's route based on source MAC hashing. And then there's route based on originating virtual port, right? Those are all the three basic load balancing options you get with a standard switch. You also get them on a distributed switch. The irony here is that none of those are really actually load balancing. They're all load spreading algorithms more than anything else. To actually achieve true load balancing, well, this is what you get with a distributed switch as another option. As you see, we've highlighted it, route based on physical NIC load. This is different than load spreading. In fact, what we'll do here is looking at when an ESX server has multiple adapters to choose from, we'll look at the host level, how those uplinks are being utilized. If one of the adapters is being utilized over 75% of its potential bandwidth over a 30-second time period, it will then readjust the highest by bandwidth utilized virtual machine will be migrated over to another adapter on that same host, right? We're not doing a vMotion here. We're just offering the ability to balance the I/O across all the available uplinks that are all part of that same port group, right? So a true teaming configuration here with real load balancing. Now, other things that a distributed switch offers are the choice of the discovery protocols. A standard switch only offers the ability to perform Cisco discovery protocol. You can enable that using an ESX server's command line. On a distributed switch, you have the ability to choose from Cisco discovery or a vendor neutral link layer discovery protocol. With this, you're able to provide the discovery protocol in a mixed environment where you might have Cisco hardware on the physical network side, but you might have other networking constructs maybe at a virtual interconnect level. This becomes a vendor neutral way to advertise your network configuration, right? These discovery protocols are great that they help provide connection information about the virtual switch and advertise that to the physical network. Just like we can actually gather that same information from the physical network into the virtual network. Setting this up is actually pretty easy. Again, on the switch, as opposed to on the port group, you edit the settings for the switch, and then you can enable discovery protocol. By default, it listens for Cisco discovery traffic only. You can adjust that so that it actually advertises to the network about the virtual switch, or you can actually have it do both, where it actually advertises and listens, or you can actually change the type from Cisco discovery to the open standard of link layer discovery protocol. Another great feature of a distributed switch is this static port binding characteristic. We mentioned this earlier. A standard virtual switch uses ephemeral port binding, which means that the host is in charge of assigning the switch ports, but the host assigns the ports in an ephemeral method, meaning that anytime there's a power state change with the virtual machine, it'll get assigned a new port. With a distributed switch, we have static assigned ports. Now, you actually have some choices here, but you'll notice that it says port binding. Static binding is the default setting, but there's also the ability for maybe backwards compatibility, the ability to provide ephemeral port binding. It says here no binding occurs. Basically, what you're doing on a distributed switch is you're offering the ESX server to take over the port management for some backwards compatibility purposes. But normally the best practice is to leave the port binding to static, putting vCenter in charge of the distributed switch port assignments. One thing you get to also choose, though, is you'll notice in our screen capture that we're doing static binding. There's 8 ports, that are assigned that port group by default. Now, each port group can have their own binding settings if you like, right? Here we are in this one port group with a static binding association, and it's got 8 ports that are in that port group. That's when you assign VMs, they'll start accumulating those different switch ports. What if you add a 9th VM to that port group? What's going to happen? Well, you could have a choice here in how this gets updated to have 9 ports. You could either let the port group add the ports for you automatically, or the admin could be the one who assigns the ports instead. Now, that's your choice. Do you want to have control or do you want to have flexibility? The default is to be flexible. The port group has what's called an elastic port allocation policy, where that anytime that we start adding more VMs to a port group than there are actually ports present, the port group will add 8 more ports for you automatically. So it basically is an elastic auto-growing set of ports on every port group. If you had chosen fixed on the other hand, well, now the admin will have to actually add the port to the port group in order for the VM to be assigned to the port group. This puts some control here in deciding how ports will be assigned. But, in the era of self-service, being able to add virtual machines to the network from, say, a self-service portal, having an elastic port group is actually the best practice, and it is actually the default setting. And then let's see, another feature we get is traffic filtering and marking. Now, what we have here is the ability for a distributed switch to offer support like a physical switch would offer in terms of filtering traffic and marking traffic for quality service purposes. What you can do with this policy is set up either an allow policy for maybe one type of traffic and then block it for everything else, or you can have a block policy that impacts one type of traffic and allow everything else. That's your choice in how you want to set up your access control policy. And in addition to that, you can also add markings to the different headers of your networking traffic. For instance, you can add a quality service header to a Ethernet header using class of service. You can add a IP header attribute for what's called differentiated services code point. So depending on how you're providing your quality service, you can add that to this configuration. What it allows for is that if you're setting up different prioritizations in the virtual networks and you wanted to continue that policy into the physical network, one good way of doing that is by leveraging this ability to tag your traffic as it leaves the virtual network. So we'll take a look at all this on the next break, or after the next break. We'll come back and show some examples of this. So stay tuned. We'll be talking about that shortly.